Hello and welcome to Lesson 5.5, Indirect Proof and Inequalities in One Triangle. Hopefully you've had a chance to go through the note packet and fill out the vocabulary for this lesson. If you haven't done so, pause the video and do that now. It's going to make watching the video a little bit easier. And then once that's done, if you would complete these warm-up problems, you will need to remember how to write a conditional statement. That is any statement in the form if blank, then blank. Make it an if-then statement for number one. And the contrapositive of the conditional given to you. Remember, contrapositive is where you change the order of the hypothesis and conclusion, and you negate both parts. So you add the word not in, or make it the opposite of what it says. And then for number three, show it as false by giving a counterexample, something that satisfies the hypothesis but does not satisfy the conclusion. Take a few moments and come up with some answers. Alright, hopefully you've had a chance to go ahead and take a look at these. The conditional form of this phrase, an isosceles triangle has two congruent sides, could be this. If a triangle is isosceles, then it has two congruent sides. You could also say, if a triangle has two congruent sides, then it is an isosceles triangle. Number two, write the contrapositive of this conditional. Remember, we need to switch the order of if it is Tuesday and John has a piano lesson, and we need to negate both of those, so it would read this way. If John does not have a piano lesson, then it is not Tuesday. And number three, we want to show that this conjecture is false by finding a counterexample. X equals 7 is greater than 6, but 2 times 7 is not greater than 14. It would actually equal 14. So that's why that's a counterexample. Okay, today's objective, we are going to be applying inequalities in one triangle. You notice the lesson is called Indirect Proof. We're not really going to talk about what an indirect proof actually is much in this lesson. We'll refer a little bit more to it in class, but for the video notes, you will not be required to know what an indirect proof is. So, let's go ahead and take a look at the first part of your notes here. The positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. So, we have these two theorems. You should have these written down already, but let's take a look at what they say. First, if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. The larger angle is always opposite the longer side, as long as we don't have an isosceles triangle. And also, if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. Very similar to the converse of what we just said. So the relationship of the angles are in direct correlation to the relationships of the sides. So we want to order the angles F, G, and H according to what we can recognize from their sides. So we want to first take a look at the sides. The shortest side is GH. GH. And so the smallest angle is across from that side, so the smallest angle is F. The longest side is FH, 20.4, so the largest angle is G. And the angles from smallest to largest would be F, then H, then G. Alright, let's take a look at part B. Now, we're only given two of the angle measures in this triangle, but because all three angles add up to 180, we can find the measure of angle R very easily. 60 plus 72 is 132. If I take that away from 180, we get 48 degrees. So the measure of angle R would be 48 degrees. And so the smallest angle is R, so the shortest side has to be across from R, PQ. The largest angle would be Q, 72 degrees, so the longest side is PR. So the sides, in order from shortest to longest, would be PQ, QR, then PR. Let's take a look at example 1C. Write the angles in order from smallest to largest. Why don't you take a few moments to get that done, and then we will check our answers. Pause the video if you need more time. Alright, you'll notice that the smallest side is AC with a measurement of 9, so the smallest angle is B. The longest side is AB with 19.5, so the largest angle is C. So the angles go from smallest to largest, B, A, then C. All right, we've got a right triangle where one of the acute angles is 22 degrees. Why don't you find the other acute angle so that you can order the sides from shortest to longest? Pause the video if you need more time. Okay, the measure of angle E is 68 degrees when we take 90 and 22 away from 180. So the smallest angle is 22. The largest angle is 90. So the smallest angle, 22 degrees here, shows me the shortest side is EF. The largest angle is the right angle, F. So the longest side is DE. So the sides in order from shortest to longest are EF, DF, then DE. Okay, a triangle is formed by 3 segments, but not every set of 3 segments could form a triangle. So in this example, segments with lengths of 7, 4, and 4 could be a triangle. Now what do you notice about those numbers? Well, 4 and 4, if I were to add those two, it gives me more than 7. But what if I took segments of lengths 7, 3, and 3? This 3 units and this 3 units do not add up to more than 7. 3 plus 3 is 6. So what we notice is that a certain relationship must exist among the lengths of 3 segments in order for them to form a triangle. The sum of any 2 side lengths of a triangle has to be greater than the third side length. So AB plus BC must be greater than AC. BC plus AC must be greater than AB. And AC plus AB must be greater than BC. Now, there are 2 out of these 3 relationships that are always going to be obvious because one side is already bigger than this third side on the other. But the 2 we must always check for are the 2 shorter ones. The 2 smaller measurements must have a sum greater than the longest measurement. So we're going to tell whether a triangle can actually have these given side lengths based on that fact. And the one thing we have to check are the 2 smaller numbers to see if they add up to more than the third side. 8 plus 13 is 21. 21 is not greater than 21. Since these 2 sides don't add up to more than the third side, the triangle inequality theorem says this cannot give a triangle. These cannot be the side lengths of a triangle. No, by the triangle inequality theorem, a triangle cannot have these side lengths is what you should write. So let's try example 2b. The longest side, or potential side, is 9, so I have to check the sum of the other 2. If I add 6.2 and 7, that is greater than 9. 13.2 is greater than 9. If I added 6.2 and 9, that is still greater than 7. And 7 plus 9 is still greater than 6.2. But again, this first one is the main one you have to check. Yes, the sum of each pair of lengths is greater than the third side. In example 2c, we have to do a little bit more work. Because they give me a value for t, I have to set up and evaluate each expression for t to find the 3 measurements that I'm using. So we're going to plug 4 in for t in all 3 cases here. First, t minus 2 when t is 4 gives us a side length of 2. 4t when t is 4 gives us a side length of 16. And t squared plus 1 when t is 4 gives us 17. So if I were to add any 2 of these, I should get more than the third if this is a triangle. So we're going to compare those lengths. 2 plus 16 is greater than 17. 2 plus 17 is greater than 16. And 16 plus 17 is greater than 2. So our answer is yes, the sum of each pair of lengths is greater than the third length. Let's take a look at example 3. The lengths of 2 sides of a triangle are 8 inches and 13 inches. We want to find the range of possible lengths for the third side, and this is where it can get a little bit confusing if you don't remember how to write a range of possible lengths. We're going to use inequalities to do this. Now, either 8 and 13 are the smaller 2 of the 3 sides, or 13 is the longest side and the third side is somewhere between 8 and 13. So we're going to let x represent the length of the third side. And then we're going to apply the triangle inequality theorem. Either x plus 8 has to be greater than 13, and so we would subtract 8 from both sides, so x has to be bigger than 5. Or x plus 13 has to be greater than 8, and x would have to be greater than negative 5. This is something that isn't actually going to help us, because a side length cannot be a negative number. So it doesn't matter that we got an answer for this one. But if I add the other two, 8 plus 13 is greater than x, 21 has to be greater than x. Well, that means 21 is as large as the length could be, and it couldn't actually equal that. It would have to be less, x would have to be less than 21. So if we combine the inequalities, x is between 5 and 21. This is how we write a range of possibilities. 5 is less than x, and x is less than 21. Or x is between 5 and 21. Notice that x cannot equal either of these. There's no underline beneath the inequality symbols. So why don't you take a few moments and try and figure out what the range of possible lengths could be when two sides are 22 and 17. The first thing you want to do is let x represent the length of the third side, and then set up your inequalities to figure out that range. Take a few moments, pause the video if you need more time, and then we'll see how you've done. Okay, these ranges are what you should get. If x plus 22 would have to be greater than 17, so x is greater than negative 5 when you subtract 22 from both sides. But again, the negative value does not help us, and so we can eliminate that as a possibility. X is greater than 5 is what we get when you add 17 plus x is greater than 22. And then our maximum value when you have 22 plus 17 is greater than x is 39. So the minimum value is 5, the maximum value is 39. So x is between 5 and 39. That length of the third side is greater than 5 inches and less than 39 inches. Alright, that concludes the examples for Lesson 5.5. Why don't you take a few moments to try and work out this lesson quiz. There will be two parts. Find some extra scratch paper or extra space in your note packet and try and work out these problems, and pause the video. When you're ready, you can click play and see the results. Okay, if you've had a chance to work these out and have clicked play, you are ready to see what the answers are. The order of angles in order from smallest to largest is C, then B, then A. For number 2, the sides in order from shortest to longest are DE, EF, and then DF. And here are 3 more questions in your lesson quiz. Again, pause the video if you need more time. Okay, hopefully you've had a chance to complete these. Let's take a look at your answers. For number 3, the range of possible lengths for a third side. X could be between 5 and 29. Number 4, can these be sides of a triangle? No. 2.7 plus 3.5 is not greater than 9.8. Alright, number 5, Ray wants to place a chair so it is 10 feet from his television set. Can the other two distances shown be 8 feet and 6 feet? Yes, the sum of any two lengths is greater than the third length. Alright, hopefully this has helped explain a little bit more. We will talk more about triangle inequalities in class, and make sure that you also watch the next video for lesson 5.7, as we will go over both of those lessons in class with assignments over both lessons.